Okay, I sent you solutions to the last homework assignment, which was solidifying the derivative, wrapping up all the concepts and applying them to the behavior of functions and behavior of the derivative functions. But I noticed that the solution for page 2, one page. All right, so here goes. Okay, um, this is the last homework assignment that was assigned prior to the test, which was the lesson on solidifying the concept of the derivative, and it wrapped up everything that we had in the unit, at least as far as conceptually. Didn't practice a lot of derivatives. It didn't do the limit definitions, but it was using them to describe behavior of the original function versus the behavior of the derivative function and how they're related. But I noticed, or at least I thought, I could be wrong, I think the solution that I sent you was a different function than what is displayed on page 2. If I sent you the correct one, then great. If it's a different one, not a bad idea to study that one too. But let's go ahead and attack this one and see what we can do here. Consider this function 3 times the square root of x plus 2 cosine of x. And what do we want to do? It's g, and it's pictured. So it is this is the graph of g, not g prime. So it's just the regular function. And I'm glad they graphed it for us. Number 5 says algebraically find g prime. Okay. So this is your practice of doing the derivative. So, I'm going to start out with g of x. The way it's written is 3 square roots of x plus 2 cosine of x. I would do my rewrite, 3 x to the half plus 2 cosine of x, not very exciting. Algebraically, g prime of x would be the 1/2 times the 3, keep the x, take 1 away from a half, that's a negative half. Then the derivative of cosine is negative sine, so it's minus 2 sine of x. And it says express your answer as a single rational function with positive exponents. Well, that's not positive exponent, and so I need to fix it. And so that becomes 1/2 times 3 is 3/2. The x comes downstairs, which makes it positive exponent minus 2 sine of x. And is that all we wanted to do? Simple, rational. He wants rational. So that it is rational. To make it simpler to use, though, I would like to picture it as 3 over 2 square roots of x minus 2 sine of x. Okay, sketch the graph of g prime on the axis to the right, then state the value of x where the graph of g of x has a relative max or min. Justify your answers. So he wants us to graph that. Since we have a trig function, and I don't have really a grid that has, like pi over 2, and I don't have pi, and it's probably a calculator problem. So why don't we go get some points from my calculator, and I'll put it on there. I'm pretty sure this would have been a calculator problem. At least on that grid, it's not. The only thing I want to make sure is it's definitely undefined at x is 0, because square root of 0 in the denominator is bad. But the only points I could actually probably try to find would be, I don't even know what that, like the square root of pi would be silly. So I'm gonna I could use pi. The sign of pi is easy to do. That's 0. But I would have to do, what, 2 times the square root of pi down here, and I don't know, square root of pi. Square root of 3 is between 1 and 2. I could probably do it. 3 divided by, it's either 3/2 or it's going to be 3/4, between 3/2 and 3/4. That would be at pi. Pi is roughly here. Pi, and then what did I just say? 3 divided by 2 is 3/2, and then 3 divided by 4, because the square root of pi is going to be less than 4. So that would be a 2, 3/4. So the best I'm going to do is at pi might go up to 3/4, so it's going to be here. But then if I do 2 pi, that would be 6 point something. That would be over here. So sine of 2 pi is also 0. So the square root of 2 pi, which is like the square root of 6, would have to be between 2 and 3. So again, it'd either be as high as, 3/6, a half. So around here, it could go up to a half. So it's not very pretty. The graph's not really good. But I'm going to go to my calculator. I'm going to key it in. I'm going to change my scale to try to match this up, and then I'll come back. Okay, I'm back, and there's my picture. Let me zoom in a little bit to see what's going on here. So if that's my derivative, and I'm comparing that to the function, let's just try to see what's happening here. The function shows a maximum here. That's around a 1. So if I look at around a 1 here, right here, I have it. It's lined up. I could probably scoot that over to try to make it match up a little better. Let me try to move it over, get it to the same scale as that. Okay, close enough. So you see that this relative max lines up to the 0 of the derivative. This relative min lines up to the 0 here of the derivative. And I'm only going all the way to 7, so that graph goes a little more than 7. 7 ends here. Here. So I don't know if I have another, if he gave me another min or max up there. Let me see. No, he didn't. He didn't actually go to 7. He went to 6. So at 6 is kind of where I'm ending right here. Oh, it's not writing. Let me write again. I liked writing. 6 ends here. Okay. So it seems to be pretty much matching with the zeros. And what was he asking me to do? State the values of x where the graph of g has a relative max or min and justify your answer. Well, obviously, I just did it. I justify it by saying round x is 1. X equals to 1 was a relative max. And that meant max means the derivative had to be positive to negative. And there it is, positive to negative at that 0. At this relative, so f prime of x changed from positive to negative. And at x equals to, it looks to me like 3 was my relative min, because, or min means it had to go from negative to positive, and there it is. It was negative, right here, to positive. f prime of x, was it f or g? I'm sorry, it was g. G prime of x went from less than 0 to greater than 0. Okay, that's all he wanted. A lot of work to get that graph. Based on the graph of g, okay, that's the top picture that they did, with the slope of the tangent line, be positive or negative at 4.5. So if I'm looking at g at 4.5, obviously the slope is positive. Compare it to the derivative, 4.5. It's also above the graph. It's above the x-axis, so it matches up perfectly. Justify your answer. Well, I'm going to justify it using the derivative. At x equals 4.5, the tangent line will be with a positive slope, since g prime of x is above the x-axis. Use the equation of g prime of x to verify the answer in question 7. I did, but he wants me to use the equation. So what was my function? G prime of x was, I'm going to round that to 1.5, x to the negative 1/2 minus 2 cosine of x. Is that what I wrote up there? I don't remember. Oh, sine, I'm sorry, sine. Sine of x. So I'm going to go g prime at 4.5 is approximately, and I'm going to go to my calculator. I already have the derivative into the calculator. That's how I got that graph. So I'm just going to go to the calculator. So let me pause it. Okay, I put the picture, and let me zoom in here to see what I find. I found that at around 4.5, y is a positive 2.6 something. There it is, above the x-axis. So it matches, all right? So equals approximately, well, I better put what that was. It was approximately 2.63. 2.63. Find the equation of the tangent line to the graph at x equals to 4.5 of the function. Well, g of x is equal to, let me go back up and look at the original problem, was 3 square roots of x plus 2 cosine of x. 3 square roots of x plus 2 cosine of x. And so I'm going to plug g of 4.5, go to my calculator, I'll come back with the answer is approximately, I already know that g prime of 4.5 is approximately 2.63. You know, I better practice what I was preaching. We need 3 decimal places. So I'm going to come back and make sure I put 3 decimal places for that derivative, 3 decimal places for the function. I'll be back. Okay, I went and found out that g of 4.5 was roughly
2.662, 3 decimals, and the derivative was more accurate. I'm sorry, I have it reversed. The function was 5.942. 5.942, and the derivative was 3 point, it's actually 662 to do it exactly at 4.5, 662. So either way. And so the equation of the tangent line will be y minus g of 4.5 equals to g prime at 4.5 times x minus 4.5. So plug that in, y minus 5.942 equals to 2.662 x minus 4.5, and there I would just leave it. And let's see, 10. Use the equation of the tangent line at x equals 4.5 to approximate 4.1. Now 4.1 is so far away from 4.5, it's 0.4 away. It's not going to be as accurate, but use this equation of g to find, so we're using the equation, then use the equation of g to, well, we already know the equation of g to get the, well, we can get the 4.1. G of 4.1 would be 3 times the square root of 4.1 plus 2 cosine of 4.1. So let me go to my calculator and get that answer. And then let me use the tangent line, which was that. So I need to just move the 5.942 to the other side. So I want y to be equal to the, already forgot, it was 2.662 times x minus 4.5, and then I'm going to have to minus the y1, or the g1, which was 5.942. And so that, yeah, 5.942. And take that equation and do y of 4.1. So I'm going to have the actual answer, then I'm going to have the approximated answer. And so I'm just, since I have both equations in my calculator with y1 and y2, I can just plug in 4.1 to my g, and I'll have that answer. And then, well, I don't have this equation with the tangent line, so I'll have to put that in my calculator. And so that'll be, that will actually be, y of 4.1 will be equal to 2.662 times 4.1 minus 4.5 minus 5.942. So I'll be right back. Okay, I evaluated my function, the original function at 4.1, and got 4.924. Evaluated that tangent line at 4.1, got 4.877. And was there any other question? Is the tangent line approximation under or over? Explain why based on the graph. Well, obviously, my tangent line is under approximation. So I better look at the function and examine the concavity at the 4.1. So let's go up to the function. That was a picture they gave me. 4.1 is about here, and the concavity from here to here is concave up. So if you draw your tangent line at the 4.1 about here, No, I'm sorry. Tangent line would have been at 4.5. 4.5 was here. Draw that tangent line. Realize 4.1 was here. And if you look, the line is underneath the function, so therefore that line will be underneath the curve by a little bit. Concave up, it makes sense. It actually does make sense to me that since the tangent line is under the curve and the curve is at a concave up portion, the approximation would be an underestimate. Boom. All right, there's the page. Let me take a screenshot of that page or print that page. I don't know, somehow, I don't know how to do it. Let's see. So I can send this out to everybody. I can't seem to take a picture of it. Okay, I'm recording again, but I didn't get a picture. My picture didn't want to copy. Try this again. There it is. Just screenshotted it. Okay, and plus you have it there in the video, but I will post this video up and also give you a copy of the printout. And if I'm wrong, send me a message. Correct me, you get points. Hasta luego. Let me just, so I'm just going to